Hello everyone, this is Harrison Galway, and today I'll be teaching you how to work with the two special right triangles, the 30-60-90 triangle and the 45-45-90 triangle. So let's first take a look at the 30-60-90 triangle. We know that this other acute angle must be 60 because the two acute angles in a right triangle are always complementary, they add to 90. So this other angle we know is 60. So indeed, this is the 30-60-90 triangle. Now, I'll be referring to the sides of this triangle as the short leg, the long leg, and the hypotenuse. Right? The two sides of a right triangle touching the right angle are called the legs, and the side across from the right angle is the hypotenuse. The short leg will always be across from the 30-degree angle, and the long leg will always be across from the 60-degree angle. Now, let's say the short leg is some number, we'll just call it x. The hypotenuse is always double the short leg. So if the short leg is x, the hypotenuse would be 2x. The long leg, on the other hand, is always root 3 times the short leg. So if the short leg is x, the long leg is root 3x. Okay? And to summarize the relationships here, to go from the short leg to the hypotenuse, we just have to multiply by 2. But to go from the hypotenuse back to the short leg, well, that's the opposite, so we'll need to divide by 2. On the other hand, to go from the short leg to the long leg, we multiply by root 3. So to go backwards from the long leg to the short leg, we'll simply divide by root 3. And that's it. Also notice that we'll never go directly from the long leg to the hypotenuse. I don't have any arrows connecting those. We'll always use the short leg as an intermediary. So now let's look at the 45-45-90 triangle. Now this one, it's not labeled, but we know that these two legs here are congruent. They're the same length. And the isosceles triangle theorem tells us that if the two legs of a right triangle, or if two sides of a triangle are congruent, then the opposite two angles are also congruent. So these two angles we know are the same. Remember also that the two acute angles of a right triangle need to be complementary. And if these two angles add to 90, and they're also the same, they must both be 45 degrees. So this is our 45-45-90 triangle. Now, this triangle is simpler because it's isosceles. Let's say that one of the legs is x. Well, the other leg will just be x as well, right? The two legs have the same length in a 45-45-90 triangle. The hypotenuse, meanwhile, is root 2 times the length of the legs. So to go from a leg to the hypotenuse, we just need to multiply by root 2. But to go from the hypotenuse back to the leg, well, that's the opposite, so we'll divide by root 2. And that's it. That's everything you need to know to fill out these special right triangles or to solve for missing sides. So let's try a couple examples. So in this first example, first of all, this angle right here must be a 30-degree angle because if the other acute angle is 60 and the two acute angles are complementary, this one must be 30. So we're looking at the 30-60-90 triangle, and we're given the short leg, the leg across from the 30-degree angle. So you'll recall that in order to go from the short leg to the hypotenuse, we simply double the length of the short leg. So 2 times 3 is 6. To go from the short leg to the long leg, we multiply by root 3. So the long leg will simply be 3 root 3. Done. Again, to summarize, to go from here to here, times 2. To go from the short leg to the long leg, times root 3. All right, moving on to the next example. We're looking at the same type of triangle. It's still a 30, 60, 90 triangle because we know if this acute angle is 30, this acute angle must be 60. But this time we're given the hypotenuse. Now, we can't go directly from the hypotenuse to the long leg, but we can go from the hypotenuse to the short leg. And you'll recall, if to go from the short leg to the hypotenuse, we double, then to go from the hypotenuse to the short leg, we'll just half. Right? So we'll take 4 divided by 2, that's 2, and that's the short leg. And just like before, to go from the short leg to the long leg, we multiply by root 3. So 2 times root 3 is 2 root 3. Done. Next. Another 30, 60, 90 triangle. This angle must be 30 because the two acute angles are complementary. And this time we're given the long leg of the 30, 60, 90 triangle. And to go from the long leg to the short leg, we divide by root 3. So we'll take that length, 5 root 3, and we'll divide it by root 3. Well, then the root 3's just cancel, and we're left with 5. So that's the length of the short leg. Then to go from the short leg to the hypotenuse, you'll remember we just double. So the hypotenuse is 10. Done. A couple more of these 30, 60, 90. So again, here we're given the long leg, and just like the last example, oh, and I should mention this is definitely a 30, 60, 90 triangle. To go from the long leg to the short leg, remember we divide by root 3. But there's a little added bit here, because if we take the long leg 7 and divide it by root 3, we're left here with a fraction where the denominator is irrational. So we need to rationalize the denominator. And to do so, we'll just multiply the numerator and denominator by root 3. After all, root 3 over root 3 is just 1. So we're really just multiplying this fraction by 1. But by doing this, we will rationalize the denominator. The numerator here turns out to be 7 root 3. And the denominator is, well, root 3 times root 3 is just 3. So that's it. This side here, the short leg, is 7 root 3 over 3. Now, in order to go from the short leg to the hypotenuse, just as before, we simply double. So 7 root 3 over 3 times 2 is 14 root 3 over 3. When we double a fraction, we just double the numerator. So we get 14 root 3 over 3, and that's it. One more of these 30, 60, 90 triangles. This missing angle is 30. To go from the hypotenuse to the short leg, we simply cut it in half. So that's going to be 7 root 2 over 2. Can't simplify that fraction, so we'll leave it. Then to go from the short leg to the long leg, we multiply by root 3. So we can do our work elsewhere. We'll take the short leg, 7 root 2 over 2, and multiply it by root 3, which is the same thing as root 3 over 1. What will that come out to? Well, on the top we'll have 7 root 6, because root 2 times root 3 is root 6 over 2. And that's our final answer. Done. So that's how you handle those 30, 60, 90 triangles. Now let's look at some 45, 45, 90 triangles to get some practice with those. So again, we know that if these two sides are the same, these two angles must be the same, and so they must both be 45 degrees. So this is indeed a 45, 45, 90 triangle. And for such triangles, the two legs are congruent. So if the first is 3, the second will also be 3. Now for these 45, 45, 90 triangles, to go from the leg to the hypotenuse, we multiply by root 2. And 3 times root 2 is simply 3 root 2. Done. Another example. We're told these two acute angles are congruent to each other, so they must both be 45 degrees. And for these 45, 45, 90 triangles, the two legs are congruent, so this one must also be 5 root 2, just like the other. And again, to go from the leg to the hypotenuse, we multiply by root 2. And what's 5 root 2 times root 2? I can show my work over here on the side. 5 root 2 times root 2. Well, we can just multiply those root 2's together. And root 2 times root 2 is simply 2. So we just get 5 times 2, which comes out to 10. Done. Next. So same type of triangle. Again, we have the 45, 45, 90 triangle, since those two legs are congruent. However, this time we're given the hypotenuse and asked to find the two legs. Now, when we went from the leg to the hypotenuse, we multiplied by root 2. So to go backwards, we'll just divide by root 2. And so we'll do 6 divided by root 2. But remember, we can't leave fractions with irrational denominators, so we'll have to rationalize that by multiplying by root 2 over root 2. That gives us 6 root 2 over 2. And so that is the answer, 6 root 2 over 2. The two legs have to be congruent, so the other one is also 6 root 2 over 2. Next. If the first acute angle is 45, the second one must also be 45. So it's a 45, 45, 90 triangle. To go from the leg to the hypotenuse, we multiply by root 2. So to go from the hypotenuse back to the leg, we'll divide by root 2. So that'll give us 7 root 5 over root 2. Again, we need to rationalize the denominator. We'll just multiply by root 2 over root 2, which will give us 7 root 10 over 2. The two legs are always the same for these triangles, so this is also 7 root 10 over 2. Voila. One more problem. Another 45, 45, 90 triangle. If the sides are congruent, then the angles are congruent, and if they're congruent, they must both be 45. Since the legs are congruent, and one of them is root 10, the other must also be root 10. And to go from the leg to the hypotenuse, we'll just multiply by root 2. But what's root 10 times root 2? Well, that's just root 20. But this is a radical that we can simplify, because 20 factors into 4 times 5. So we could rewrite this as root 4 times 5. We could separate those into root 4 times root 5. And root 4 is just 2. So 2 root 5. And that would be it, 2 root 5 for our hypotenuse. And done. So that is how you work with those special right triangles, the 30, 60, 90, and 45, 45, 90. Hope this video was helpful. Thank you very much for watching. Please check out my other videos, and take care.